So in this video, we're going to talk about Newton's first law of motion, and we're going to do this a lot more specifically, looking at more details. But the idea is that Newton's first law of motion is also called the law of inertia. So inertia, please make sure you know how to spell this word, inertia. So this slide should look familiar. It's exactly the same first slide that we had in the overview. So the first law again says an object at rest will remain at rest, and an object in motion will remain in motion at constant velocity unless an unbalanced force acts on it. So again, it's going to stay at rest, and if it's in motion, it's going to go constant speed in a straight line. Constant speed, constant direction. In other words, things tend to keep doing what they're already doing. So what is inertia? Inertia is the tendency of an object to resist a change in motion, or it's the tendency of an object to not accelerate. So inertia is the measure of laziness in an object, if you want to look at it that way. So the idea is laziness is not wanting to change, right? So not wanting to get up, not wanting to stop, something like that. So inertia is the measure of laziness. Its tendency to resist change in motion. So if you change your motion, then you will accelerate. That's why these are the same idea. So what effect does mass have on inertia? Well, the greater the mass, the greater the inertia. It goes back to our overview example of the car versus the truck. A car has a much smaller mass, so it has a much smaller inertia. When you hit the gas, it's going to start moving. Whereas with a large truck, you know, your big semi-trucks, it has a greater mass, which means it has a greater inertia or greater laziness. And so when you hit that gas pedal, it's not really going to accelerate very quickly at all. It has a greater force required to get it moving. So a heavier object in motion is also more difficult to stop. And again, the best example of this would be that car versus truck. If you come around a corner and traffic is stopped, if you're in a car, you can hit your brakes and you will stop. But if you're in one of those humongous trucks, you come around that corner, you hit the brakes, you don't stop as quickly. It takes you much longer to stop than in a regular car. So a heavier object at rest is more difficult to move. And so we already talked about this one. So the idea is mass and inertia have a direct relationship. Direct relationship means as one goes up, the other goes up. So mass goes up, inertia goes up. Direct relationship. So a fly and an 18-wheeler, that's your big semi-truck, are both moving at 15 miles per hour. Which one would you rather be hit by? Well, obviously you'd rather be hit by the truck. No, I'm just kidding. You'd rather be hit by the fly. And the reason why is because it has a smaller mass, so if it were to hit you, it would probably just bounce right off. Whereas if you were to get hit by an 18-wheeler or a semi-truck, then of course it's not going to bounce off of you. If anything, you're going to bounce off of it, get seriously injured and things like that. And it's because the fly has less inertia than the semi-truck does. So our second question is, would you rather have to move an empty file cabinet or a file cabinet that is full of paper? Well, of course you'd rather move the empty one because the one full of paper has more mass. All of that paper adds mass to the filing cabinet. So more mass means it's harder to get moving. It's lazier than the empty file cabinet. So the empty file cabinet would have less inertia, be much easier to move. So if an object is moving, its tendency is to keep moving in a straight line path. So why does the path of a baseball, right here, or a cannonball curve towards the ground? So why does it? It's because both are being affected by gravity. And gravity is an additional force. The idea of inertia and the idea of that first law is that it'll keep moving in a straight line path until a force acts on it. So here with the cannonball, as soon as it's launched, gravity is pulling it down. That is an additional force. For the baseball, you're throwing it up, but as soon as you let go, it's being pulled back down because the force of gravity is changing the path. If you were to toss an object where there's no friction, such as outer space, it would move forever in a straight line motion. So notice in the picture here, a cannon being fired without gravity would have that cannon instead, or that cannonball, go in a straight line path. It would keep going forever and ever and ever until a force acted on it. So without gravity, objects would go in straight line paths. A continual application of force is not needed to keep the object in motion. And that's because as soon as it's in motion, it wants to stay in motion. This is why working in space can be very dangerous for the astronauts. They have to make sure that they are tethered to something, because if they're not, and something gives them a slight little push, they're going to start moving away from the vehicle. And once an object is in motion, it will stay in motion. And the last thing you want is an astronaut to not be tethered down and to start moving away from the ship, because nothing will stop them until a force acts on them. And in space, there's not a lot of things out there to cause a force like that. So always tether if you're an astronaut. So if a continual application of force is not needed, then why do you need to constantly keep your foot on the accelerator? Well, gravity's not causing the car to slow down. Gravity's not causing the car to speed up. So if you're driving down the road, you're going horizontally, there should be no force affecting it, right? And so there should not be a constant need to push your foot on the accelerator. So why do you have to? It's because there is another force affecting it, the force of air resistance and friction with the road. So if you put your hand out the window, you're going to feel all of that air resistance that the car is experiencing. And you can move your hand up and down, you know, like doing all the waving that everyone has done. And then, of course, the tires have friction with the road. These are both forces. And those forces make it to where the object is no longer in terms of inertia. So there is some force affecting it. So what do you feel when you stick your hand out the window? You feel lots of air. And that's what your car is experiencing. That's why you have to keep hitting your foot on the accelerator. And so your car experiences the same thing. So if the force of gravity were cut off, what would happen to a satellite? So up here we have a satellite with gravity. As soon as it's let go by whatever shuttle or vehicle is releasing this particular satellite, it's going to stay in orbit. And the reason why is because this planet has gravity, and gravity is going to constantly be pulling this down. Now the reason why it doesn't actually fall is because it's going fast enough that as it's falling, it continues in the curve of the planet. And so it stays in orbit. That's why there's a specific speed that you need to make sure your satellites are at in order to make sure they stay in orbit. Now, what were to happen if, say, for example, the Earth's gravity were to stop? Well, what would happen is those satellites would then go off in a straight line motion. So, straight line motion. We hope that wouldn't happen though.